You know, what if I told you there's this really cool math puzzle, kind of hiding in plain sight, maybe even in your own backyard? Well, today, we're going to solve it. And we're going to do it by breaking down one of math's most basic but powerful ideas, the square root.
All right, picture this. You've got a garden, it's a perfect square, and you know the total area is 25 square meters. So the big question is, how long is each side? Just think about it for a sec. What number times itself gives you 25?
If you were thinking 5 meters, you absolutely nailed it, right? Because 5 times 5 is 25. And just like that, you've basically gotten the main idea of a square root. That number, 5, is the square root of 25. But come on, that was kind of an easy one. What happens when the numbers aren't quite so neat and tidy?
To figure that out, we've got a game plan. First, we'll really decode the math behind that perfect garden. Then, we're going to learn some super handy root rules. After that, we'll get into how to handle those trickier numbers. And finally, we'll put it all together and solve this puzzle for good.
Okay, let's jump in. Decoding the math. To really get a grip on this, we've got to step away from the garden for a second and just learn the language. Let's build our foundation with a few really key ideas.
So first up, the star of the show, the square root itself. Officially, it's a value that when you multiply it by itself gives you the original number. And that symbol, the one that kind of looks like a check mark, that's called a radical. It's just a fancy way of saying find the square root of whatever's inside. So writing the radical sign with a 25 inside is just math speak for, hey, what number times itself equals 25? And we already know the answer to that one is 5.
Next, we've got rational numbers. Now, I know that sounds super technical, but it's really just a name for any number that you can write as a simple fraction. We're talking whole numbers, we're talking fractions, and even the decimals you use all the time. This is going to be super important because as we're about to see, not all gardens come in perfect whole number sizes.
And that brings us right to this idea of a perfect square. Our first garden, the one with an area of 25, that was a perfect square because its root is a nice, clean, whole number, 5. In the same way, 9 is a perfect square because its root is 3, and 16 is 1 because its root is 4. You see the pattern, right? These are the easy ones.
All right, time for part 2, the root rules. This is where we get to arm ourselves with some, math superpowers. Seriously, these are 2 simple rules that make dealing with square roots, especially the tricky ones, so much easier. Think of them as your secret weapons.
Our first superpower is called the product property. And just like the name says, this one is all about multiplication. It's an awesome trick for taking big, scary square root problems and just breaking them down into smaller, much friendlier pieces. Let's see how it works.
So the rule is actually pretty simple. The square root of a times the square root of b is the exact same thing as the square root of a times b, all under one roof. This means you can either mash 2 separate roots together, or you can take one big one and split it apart. It is an incredibly handy tool to have in your back pocket.
And our second superpower? The quotient property. Now, if the product rule was for multiplication, you can probably guess what this one's for. Yup, division and fractions. This is the key that unlocks how to deal with all those rational numbers we were just talking about.
This rule works pretty much the same way as multiplication. The square root of a whole fraction, a over b, is the same as the square root of the top number divided by the square root of the bottom number. This lets you turn one ugly fraction problem into 2 way simpler ones. You just find the root of the top, find the root of the bottom, and you're done. It makes fractions way less scary. So we've got our definitions and we've got our superpowers. But what happens when things get messy? Well, welcome to part 3, handling tricky numbers. Let's see what happens when our garden isn't a perfect square anymore.
So here's the new challenge. What if your garden's area is a fraction, like 9 over 16 square meters? Or what if it's 10 square meters, a number that's definitely not a perfect square? All of a sudden, the answer doesn't just pop into your head. So how do we find the side length now?
Well, this actually splits our problem into 2 different paths. On one hand, for a fraction like 9 over 16, which is really just 2 perfect squares stacked on top of each other, we can use our new root rules to get a perfect, exact answer. But on the other hand, for a number like 10, we're going to need a different kind of tool to find what we call an approximate or, a close enough answer.
And for those approximate answers, we've basically got 2 tools for the job. The easiest, most common way is to just use a scientific calculator. But you could also estimate using pre-made tables of values. For our purposes today, though, let's be honest, the calculator is our best friend.
All right, it is time for the final step, solving the puzzle.
Let's take every single thing we've learned, our definitions, our rules, our tools, and just put it all together to crack this thing.
Okay, first up, the fraction garden. We need the square root of 9 over 16. Now this looks tricky, but wait, remember our quotient rule? We can just split this into two super easy problems, the square root of 9 on top and the square root of 16 on the bottom. And we know the square root of 9 is 3 and the square root of 16 is 4. Boom! The side of our garden is exactly 3/4 of a meter. That rule just made a complicated problem incredibly simple.
Now what about that 10 square meter garden? Well, since 10 isn't a perfect square, this is where we just pull out our calculator. We punch in the square root of 10, and it spits out an answer of about 3.162. So the side of this garden is roughly 3.162 meters long. It's not a nice clean fraction, but for any real-world purpose, it's more than precise enough.
And really, that's the big takeaway here. You are now officially equipped to find the side of any square garden. It doesn't matter if the area is a whole number, a weird fraction, or some messy decimal. You've got the rules and the tools to find the answer.
So let's just do a quick recap of the essentials. A square root is basically the reverse of squaring a number. This whole idea works for rational numbers, like fractions, not just whole numbers. And those two properties, the product and quotient rules, are your absolute best friends for simplifying things. And for everything else, a calculator is your go-to for a quick, solid answer.
So we've figured out how to find the square root of pretty much any positive number you can throw at us. But that leads to one final, kind of mind-bending question. What number, when you multiply it by itself, gives you a negative result? Think about it. A positive times a positive is positive, and a negative times a negative is also positive. So what on earth is the square root of -1? Well, that's a whole other mystery for a whole other explainer. Thanks for joining me.